These are all things you need to know. Back to your eyelids. That's a hint. What can we do with the energy, Matt?
We need to create a system where we can show that the energy is conserved and that it stays within the system and is not transferred anywhere else.
That's very good. I think we're going to assume that our system is already doing that, though. But that's exactly it. We need to make sure that energy doesn't go anywhere else. And you said something about doing something with the energy, though. Let it hit something and transfer, right? So if it hits something, what's it gonna do? Where is that gravitational potential energy going to go? To that object. And then, so what do we do next? When you hit an object, what does it generally do? Move. So, does that trigger anything?
Yeah.
What was that? It pushes back. What happens if I push it with a little energy? How far does it go?
Not as far.
What if I push it with a lot of energy?
It'll go farther because of your force behind it.
So can you think of a way of developing an experiment to find out how to find out if gravitational potential energy would be a little or a lot?
How far it bounces back upward to see how much energy is lost.
No, I mean we're almost there. We were talking about pushing an object, right?
Measure the distance.
Measure the distance of what, Gabe?
How far it gets pushed.
Oh, that's beautiful. So if it pushes it, what is the marble going to be doing on this object? And if we assume that all the energy is going to be converted into work, then can we measure how much energy the marble started out with? Yeah? Okay, so we just developed an experiment to determine height. Now what about mass? Greg, how do you think we develop an experiment to investigate how mass affects gravitational potential energy?
Drop from the same height, obviously varying masses.
I love that answer. And then how do you measure how much energy it has?
How far masses or no?
Same thing with
Yeah, same measured distance.
Yeah, the distance it pushes something. You measure the amount of work it is able to do. So, now that we're able to measure mass and height, acceleration due to gravity, if we had some rocket ships, we might be able to test that out. But for now, we're going to be happy with mass and height. And that's exactly what we have for you today. So I want you guys to partner up differently, though. Let's see, Greg and Nate, Gabe and Matt, Samantha and Dan, and Magash and Madhu will be working together. And I have a little marble and cup activity, pretty simple, but you guys are going to be making graphs and we're going to post them up later. Okay, so let's first look at mass. What kind of relationship did we see mass and gravitational potential energy having? Direct. How do you know it's direct?
Because the mass would be, if you dropped it at a certain height, it would go a certain distance on the right.
Okay. And then Ann, so what would happen if you double that height? Hello. Let Ann answer.
the gravitational potential energy would double. Well, the cup would go twice as far.
The cup would go twice as far. So, in terms of the words up here, what can you tell me?
That the energy was converted. I mean, but in terms of like the height,
So what did the marble do to the cup?
pushed it.
Pushed it. What did we call it?
Work on it.
It did work on it. And so, what was the relationship between the work the marble did on the cup and the height that we dropped it from?
Direct.
Direct. So that if I double the height, what would happen to the work that marble did on the cup?
Or double.
That's exactly right. So if I'm starting my gravitational potential energy equation, what do I just first start out with? Math. Or what were we talking about? Height, right? So we just start with height. So everyone can see that when we double this gets doubled, right? When we halve this gets halved. Alright, so now let's talk about mass. Greg, can you tell me what the relationship between mass and gravitational potential energy was?
Direct.
Direct. And how do you know that?
Just if you double the mass, it will 2 times as much.
exactly right. So, just like I was trying to get Ann to say before, can you tell me in terms of this terminology what was happening?
Double the energy, double the work done.
Mm-hmm. And how do we double the energy?
By doubling the mass.
Excellent, excellent. So how do I incorporate mass into this equation here? Put an M? Like this?
No.
No. Multiply. Why doesn't this work? I mean, if I increase mass here, gravitational potential energy still increases, right?
Yeah, but not by
Joules, that's right. So that is so important. I'm going to put it on the very important bulb.